This morning we're going to do a small review of the parent functions and transformations that you did in Algebra 2. This is going to translate later into trig, so it's important that you really kind of get a good general understanding of what each kind of number position does in terms of the graph. This will also help you later on in calculus a lot, actually. So the constant parent function, this and the linear function, we've done so much with that back in the day. But today we're going to review the quadratic, so the ones with x squared, the cubic, x cubed, and this one has multiple names, but since we've been working on rational expressions, we're going to call it rational, which is just a fraction version with x in the denominator. So just a review of things that you would have learned in Algebra 2, and with some fancy names, just in case you didn't learn those. Vertical shift is changing it up and down. So if you think about a line like y equals x, when you add 3 to it, you're moving it up 3. The y-intercept is 3. So that's what this is. If you want to move up, you need to add. And if you want to move down, you need to subtract. And that makes a lot of sense in our heads. So for example, I'm just going to make up one of them here over on the side. If we had our parent function y equals x squared, for example, if we want to move that graph up, we would do y equals x squared plus, say, 8. Okay, so that takes the y equals x squared graph and moves it up 8 spots. The next thing that we can change is the horizontal shift. So that's moving it left or right. And this part gets a little funky. So first of all, it's super important to know that when you move the horizontal part, it needs to be in parentheses with the x, or grouped with the x somehow. Okay, so where the y-intercept is kind of flying out there in free space, the x-intercept, or the x or horizontal shift, has to be grouped with it. And I'll show you that here. But this is the weird part. If you want to move it left or backwards, you add. It's the opposite of what you would think. If you wanted to move it the right, that's when you subtract. Okay? So this would go up 8, right? That's what this one would do. If we have y equals, and now we have x minus 3 squared plus 8. Now we're also moving it up 8 and to the right 3. Okay, so that's how that works. I'm going to use a little highlighter here just to make it more obvious, just in case you need that. That's up, right 3. All right, so your eyes are going to be focused on these little bits and pieces in order to make sure that you move the graph correctly. If you want to stretch, make it wider, or shrink, make it narrower, your graph, you need to multiply. You could also divide, like have a number in the denominator, but that's the same as multiplying by like 1 over 5 if you have a denominator of just 5. So I'm just going to call it multiply for now. If you want it to get wider, you're going to multiply by a number greater than 1. Okay? If you want it to get narrower, you're going to use a number between 0 and 1. So remember, this notation here means between 0 and 1. So if you multiply by a fraction, it's going to make it narrower. So let's just kind of add that here. We're going to have y equals, let's do 3 times x minus 3 squared plus 8. This this time we're multiplying and that by a number greater than 1, and this is going to make it narrower, 3 times narrower. And the other thing that we can control is negative. So if we multiply by a negative, it flips it. All right, so instead of, for example, a parabola being this way, up, it will be, this is x squared, negative x squared would look like this. So it just flips it over. So let's change this one over here. Y equals negative 3 times x minus 3 squared plus 8. So the only change we made here is we put this negative. So whatever your graph looked like, now it's upside down or backwards really, because sometimes it flips. It doesn't really look upside down. All right, so that is the gist. These are the things that you can control. And let's look at 3 examples. So if we look at this first one, this is a quadratic equation, a quadratic parent function. And so we're going to talk about what each thing does. The 4, this one out here, is going to move it up 4 spaces. All right, so 1, 2, 3, 4. So kind of like that, okay? This negative 3 is going to move it to the right 3 spaces. So we're going to take this and move it 1, 2, 3 spaces. So now it's kind of over here. And then this 1/2 is going to make it wider, double as wide. So for example, it might look something like this. Now this is not a beautiful, perfect drawing, but it's just one to give you the gist of what's happening. So it's double in size. The next one, this is a rational. This is the parent function of a rational equation. And so let's look at how we're going to move this one. This 1 means down 1 space. So it would kind of look like this. I'm just going to do the top part right now, just, hold on. Yeah, that's right. All right, down like that. The other one is going to follow the same pattern. Then we need to move it 2 spaces to the left because it says +2. So we're going to take it and we're going to go backwards 1, 2. Okay. But it's still coming along here. And then 5 means that we're going to make this thing 5 times skinnier. Okay. So it really doesn't, with this one, it doesn't look like it changes it that much, but it does. Okay. So that's how it works. The part on this one you're looking at is really the inside part, how wide it is, but it's hard for me to really draw that on this graph. That one's hard to hand draw. All right, and then the last one is cubic. This is the parent function of a cubic graph. This means up 8. So we would move this up 1, 2, 3, 4, 5, 6, 7, 8. Right? Like that. We need to move it backwards 4. So 1, 2, 3, 4. Like that. And then we need to flip it so it's backwards. So instead of being like this, it will be like that. All right, hopefully that was a good review of graphing. We're going to go over the other parts of it too, but this is the main gist of what you need to know. Let me know if you have any questions.